Okay, let's look at this example. So sorry about the quality of picture, but I'm trying to make it smaller format so that I can email it. So we have this group data distribution here. So we have the age of the individuals and we have the number of individuals here. So looking at this first column here, we have 34 individuals that are between the ages of 1 and 10. So the only difference between a group data distribution is that we don't know the explicit data that we're looking at, right? So we may have, 12 5-year-olds, another 12 8-year-olds, and 10 9-year-olds, right? But we don't know, right? All we know is that we have 34 individuals that are between the ages of 1 and 10, right? So when we usually calculate the mean, sorry about the shadow, we use x bar equals the sum of our data points divided by our total number of data points here, right? But we don't have our data points. All we have is a class of data points, right? Here in this case we have 4 classes of data points. So what we're going to do is we're going to estimate the class average by using the midpoint. So I'll call this midpoint x hat. So here's our midpoint. Right, and to find the midpoint, we sum the two values and we divide by 2. So we get 11 over 2, which is 5.5. Here we get 11 plus 20 over 2, which is 15.5. Similarly, we get 21 plus 30 divided by 2, so we get 25.5. And then the book in this case says to use 35.5 as the class midpoint for the group of individuals 31 and over. Right, so now what we want to do, so here's our data point. So we're going to just pretend that we have 34 data points of the data value 5.5, and similarly 18 of 15.5 and so forth. Right, so what we're going to do is we're going to slightly modify this formula and say that the mean is the sum of our data points times our frequency over the sum of all of our frequencies. And again, sorry about the video quality. So in this case here, our data points are our midpoints, and our F is our frequency. Right, so we can do this by hand if we wanted to, but it's a lot easier to use our calculator, right? And again, we can use our calculator for the standard deviation too. You can look in the book, there's a formula for it. Okay, so what we want to do is we want to get into stat mode. Notice that, sorry about the glare, my calculator is already in stat mode. I'm going to exit here. So to get into stat mode, again, sorry it's blurry, click second and our data button. So second, data, and then it says 1 variable statistics. 2 variable statistics we'll use later in the linear regression section. So in chapter 9 I think it is. So we're going to enter. Now it's in stat mode. There's a little stat symbol right there. So now we want to input our data. So I'm going to click the data button, and I have my X1 and my FRQ, which is my frequency, right? So here, this is going to be my X1, my X2, my X3, and my X4, and then these are going to be my corresponding frequencies. So I have 5.5 with a frequency of 34, right? 5.5 frequency of 34. And then I move down to my second data point, which is my midpoint, 15.5. It occurs 18 times. And then I move on, 25.5. It occurs 17 times. And then I finally have 35.5, and it occurs 11 times. Right, and so now I'm going to let my calculator do this. So I'm going to click the button right next to the data button, the stat var, click it, it calculates it calculates it. We have 80 data values, that's our n. Right next to it is our mean, our x bar. So we've approximated our mean to be 16.125. And then finally we have our standard deviation. This is our population deviation, which just is a slightly different formula. But for the most part, this class, we're going to use our sample standard deviation. Now, we want to be careful when we calculate our variance. If we approximate this value to be 10.94 here, our variance is s squared. So when we square 10.94, when we square it, we get 119.68 about, right? But this is a little off. Your homework system is going to mark that wrong. What we need to do is we need to use the exact value. So going back to our stat var, our standard deviation, notice this continues on who knows how many decimal places. So I want to think of this as a number itself, so I'm going to click enter. Now the calculator says I'm working with that number, and then what I can do is I can square it, and notice we get 119.85 approximately, whereas before we got 119.68. So we just want to be a little careful. So hopefully this helps you out.